In this presentation, we are going to take a look at creating custom exception types for your applications. When an error is encountered or a problem is encountered in C# code, the typical response is for the CLR to throw an exception. For instance, if we create an integer value called x and we'll set it equal to 10, then we'll do y is 0, and we'll set z is equal to x divided by y. When we execute this code, we would expect the CLR to encounter a divide by 0, and therefore divide by 0 exception is thrown from the integer divide method. The correct way to deal with something like this, besides never attempting to divide by 0, is to wrap the block of code that causes the problem within a try block, as such. Now we know we can handle the generic exception type, which is the base class for all exceptions, or we can handle a specific exception type, such as divide by 0 exception. Since that is the error we are forcing to happen, we would expect the breakpoint inside this catch block to be triggered. And in fact it is. So then we could output to the console that an attempt was made to divide by 0. Then we can correct the problem and continue. But what if we are writing an application and we encounter a problem in our custom code and we wish to throw an exception from that point? Of course, we could use one of the pre-built exception types, such as argument exception or just exception. However, sometimes you want to be a little more specific, such as the divide by 0 exception is for dividing an integer by 0. To that end, we can create our own custom exception types by deriving from exception. First, let's create the framework for our application that will require a custom exception. I'll create a person class, and this person class is going to be relatively simple. We'll create some auto properties, such as ID, last name, and first name. We're not going to bother with date of birth like we've done in so many other examples. We just need a basic object for us to store information, and then we can use these objects to test for certain conditions and throw our custom exception when one of those conditions arises. Let's go ahead and also put a constructor by selecting quick actions after highlighting all the properties. Now I will put this below, change the ID to lowercase d, and then I'll override toString. Let's assume that the ID is going to be a social security number. So then we can print ID. Let's do last name and first name. So that'll be sufficient for our person class. Let's create a list of them, and I'll comment this out. We don't really need to see that. Let's create a list of person objects. We'll call it people equals new list of person. Then we can add several person objects. We'll call this one P1 equal to new person. We'll give it an ID number, a last name, and a first name. We will add P1 to people. And then we'll create another person. And this person will have the name Williams and John. Then we'll add P2. Now, watch what happens when I do P3. I intend to leave the ID the same. And there's absolutely nothing in my code to stop this from happening. So if I print this list out, I would expect we'll see two people with the exact same social security number. And I don't need to have a breakpoint here anymore. And in fact, we do. Jane and Peter both have the exact same social security number. In most applications, this scenario would not be allowed. The problem is we have no logic in the default list of person class to prevent that from happening. Normally, you would look in the add method for this occurrence. Well, we do have an option here. Let's go back to the person class, and instead of using a generic list directly, why don't we use the power of inheritance to create a person list class that derives from list of person. And now what we are able to do is create our own version of the add method. We can't override add. That's just not going to be allowed because it is not a virtual method. And if we were to supply an add method such as this, we'll just call it obj, we have a problem in that it's hiding the base class implementation. So we have a choice. We can make it new. Now we are going to be officially hiding it or shadowing it. Or we can change the method name. We could call it add person. A third alternative would be not to inherit directly from list of person, but instead implement some of the list interfaces and then use a has a relationship with a list of person and expose only the methods that we wish and just pass them through. Let's just stick with this approach for right now, just to keep the problem relatively simple. So we'll have an add person method for our custom list. And before we actually allow the item to be added to our list, we have to make sure the ID for the given object does not exist yet. So what we're going to do is create a Boolean called found, and we'll set it equal to false. And then for each person, P in, now what is this in referencing? Normally you have a collection object that you can loop through. But in this case, we are a collection object because we inherit from list of person. Therefore, we are going to supply the keyword this as the target for our for each. So we'll get the enumerator out of this object, and therefore every P that comes back is what is currently stored in this current list. So if P.id equals the passed in object's ID, we'll set found equal to true, and we'll break out of the loop. Now there are many more efficient ways to do this. We could use something called link and use a variety of other techniques. But I think this is the most straightforward for this example because it'll help you understand the process without introducing more complex logic just to demonstrate how to select an item out of a list that may already exist. So we have now looped through the list, and if we have found the item, we will set found to true. Now if it was found, this is where we would want to throw an exception, such as throw new exception item with the ID, and then let's make this an interpolated string with the ID obj.id already exists. So we are going to throw a standard exception. Otherwise, we will add obj. So this is perfectly acceptable. We will get an exception. It's a standard exception. Then we just have to change this list of person to a person list object, and instead of using add, we'll have to use add person, because remember, we did not find a convenient way to override add. Now let's try to run this, and you'll see we do trigger that exception because we did find someone with the ID 123456789 already. So the exception is thrown. It's an unhandled exception. The program will terminate abnormally because we didn't wrap any of this in a try block. So we could wrap this whole method in a try block as such, and then I will borrow the code that we had in the comment. If you're wondering how I did the block select, I was holding down the Alt key while clicking and dragging. So run this again, and you'll see item with the ID 123456789 already exists. Okay, so nothing out of the ordinary yet. Where we want to change this is by creating our own custom exception type. Instead of relying on a pre-built exception, like exception, we are going to add a new class, and we'll say duplicate person exception. Now this is the standard way of naming an exception class. You start with the specific purpose of the exception, followed by the word exception as a suffix. Then we inherit from exception. We also want to create 3 constructors. We'll start with the default constructor, which accepts no parameters, and I will fill in the blanks after I create all 3 constructor types. The second one will accept a message. I'll copy this one. And the third one accepts something called an inner exception. So we can embed an exception in another exception. So what does duplicate person exception do as far as the default constructor? Well, we need to come up with a standard message template. So when this exception is thrown with no parameters, at least the message we send back to the user makes some amount of sense. And we have the choice. We can assign the value to the message property here because we inherit from exception. Message is a property. But notice here, get is the only property accessor available. We don't have access to the mutator. So that's out of the question. Fortunately, we do have the ability to call the base class constructor, which accepts a message string. So now we could say an item with the given key already exists. That is a fair enough description of what we are trying to say for a generic duplicate person exception. Now, this one, the second one, duplicate person exception that accepts a message already, is going to use the same base class constructor. However, instead of passing in a string literal, we're going to pass in what was given to us as this parameter. And then finally, we have the one that accepts a message string and an inner exception. And fortunately, there is a base class constructor that once again accepts both of those values. So we could say MSG followed by inner. Technically, this is all we need to do. However, one thing I like to do is to sometimes do some kind of logging, like maybe to a file or to the event log for Windows. We're not going to get that complicated now. We're going to pretend our console window is what we're going to log to. So what I'm going to do is create a private method. I'll call it handle error. And here we're going to accept just a string message. And then we can change the console foreground color to red. We'll write the message to the screen, and then we'll reset the console colors. Just need console.reset color. There we go. Then we can call this handle error, and we're going to use message, not MSG here, because we don't actually have access to an MSG variable at that level. We can pretty much do the same thing for each of them. So now anytime one of these exception constructors is called, we will output to the console window. Let's go back to program, or actually let's go back to person, and instead of throwing exception, we are going to throw new duplicate person exception. Let me fix that. And as you can see, we're using the second constructor, the one that accepts a string. Then in program, we can leave the catch exception there, but let's go ahead and add a duplicate person exception handler as well, and we'll just simply put out the message that was thrown. When we run this, you'll see the message was printed twice. Once because of handle error, notice it's red, and the second time was from the actual error handler that we had in the program class. There is no limit to the number of custom exception types you can add to your own application, and as long as you follow this template, and the handle error part is strictly optional, but as long as you follow this template, this is pretty much boilerplate. So you could copy this class over and over again, and you just have to change the name of the class, rename the constructors, and provide a more appropriate default message string for that particular exception type. And then you can have as many of these as you desire. So it allows you to be a little more specific when throwing exceptions from your own code. Clearly, these exceptions that you create will never be thrown by the CLR directly, since it has no foreknowledge about them, so these are specific to your application.